Thanks for watching my video. Today we are going to discuss our mean value theorem, which is namely our Cauchy mean value theorem. Okay, Cauchy or Cauchy mean value theorem. Statement: if two function, if in this or Cauchy mean value theorem, we have two function. Okay, but in Lagrange mean value theorem and or we have only one function. So if two functions f and g are the two functions defined on closed interval AB, then and if all these conditions are satisfied, okay, number one, continuous on the closed interval AB and derivable on open interval AB, and g prime of x is not equal to 0 for any x belongs to open interval AB. Okay, that means x is between a and b, and then there exists, if these three conditions are satisfied, then there exists a real number, or at least a real number, such that which is C. Let's say that a real number should be C, which is belongs to open interval AB, such that f of b minus f of a over g of b minus g of a is equal to f prime of c over g prime of c. That means the derivative, okay? Because if g prime of x is not equal to 0, that means g prime of c equal to 0. That means this will be infinite, okay? That's why we assume that g prime of x is not equal to 0. Now, in this, first notice that first notice that this our function g of b minus g of a should not be equal to 0. If it is equal to 0, then our function will be undefined already, or we can say g of b is not equal to g of a, okay? Meaning g of a and g of b should not be equal to, they are not equal, okay? Now consider the function. Now let us take a new function. Consider a function phi, which is our function is phi on closed interval AB, defined by, so it is defined by phi of x is equal to f of x plus a g of x. Okay. Now we are going to take our new function phi, which is between a and b in the closed interval, and which is defined by phi of x is equal to f of x plus a g of x. In Lagrange value theorem, if you take g of x to be 1, that means this or Cauchy mean value theorem reduces to Lagrange mean value theorem. Okay, then is one advantage. Okay, this phi of x is equal to f of x plus a g of x. Now where, because g of x and f of x is, we have our function, okay, and phi of x is our new function, and well, a is constant, where this a is nothing but a constant to be determined such that phi of a is equal to phi of b. Okay, we are going to determine our constant a by using this phi of a is equal to phi of b. Now if I put phi of a equal to phi of b here in this equation, phi of a will be f of a plus a g of a, and phi of b will be f of b plus a g of b. So we can find out our function or constant a, okay? Now a g of a minus g of b this transfer here equal to f of b minus f of a. This one transfer here, or I can write a is equal to f of b minus f of a over g of a minus g of b. Now I want to keep this g of b first, so multiply by negative sign, f of b minus f of a over g of b minus g of a, and such that we have assumed that g of b is not equal to g of a. Okay, now let's take this equation to be or 1, equation 1. Now phi is continuous on closed interval ab, closed interval ab, and y, or function phi is continuous because f of x and g of x is continuous here. We say that here. That means two continuous functions. The sum of two continuous functions should be again continuous function. Okay. Uh, phi is continuous on closed interval ab. Why? Because being the sum of two continuous functions. Because phi is or the sum of two continuous functions, that means that it will be continuous again. Continuous on closed interval ab, and phi is derivable on open interval ab, open interval ab, y being the sum of two derivable or differentiable function on ab. Okay, because our phi of x is f of x plus a g of x, so f of x and g of x are derivable. Here we have our condition here, derivable. That means sum of two derivable functions should be or derivable function again, which is our phi of x. That means our phi is continuous, differentiable, and phi of a is equal to phi of b. Okay, we take, and also phi of a is equal to phi of b. So that means Euler's theorem is satisfied. That means by Euler's theorem such that a real number c belongs to open interval ab such that phi prime of c is equal to 0. This is our Euler's theorem. Okay, but now since we need phi prime of c, so we are going to differentiate our phi of x. Okay, so phi of x differentiation is f prime of x plus a g prime of x. Now if I replace x by c, phi prime of c is equal to f prime of c plus a g prime of c. Since this is 0, which is f prime of c plus a g prime of c, therefore I can find out a again, so which is f prime of c over g prime of c but negative. Question 2. Now if we compare equation 1 and 2, from 1 and 2. From 1 and 2 or constant, a is both the same. Okay, a equal to a, that means this one will be minus f of b minus f of a over g of b minus g of a equal to this a is this one minus f prime of c over g prime of c, so minus cancel. Lastly we get f of b minus f of a over g of b minus g of a equal to f prime of c over g prime of c. So which proof or Cauchy mean value theorem. Okay, this equal to this one.